Section 6.6 is on solving absolute value inequalities. So now we have absolute values and inequalities. So you're going to have more than one solution because now we have our inequalities back, not an equation. So here's an example of something that's less than and something that's greater than using absolute values. So if we look at this first one, we want to graph the values of x, the absolute values of x, that are less than 3. Now remember, absolute value means the distance from 0. So I want to graph a distance that's less than 3 to 0. So that means that I need to put a dot at 3 and negative 3, because remember, this x could be a positive or negative, we don't really know. And they're open because it's not or equal to. And I want a distance that's less than 3. So I could have a distance of 2, 1, 0, but I can't have anything greater on either side. So I'm going to shade in between these two dots. But if I look at it just the opposite, if I want greater than 3, and I still have my two dots at 3 and negative 3, if I want a distance that's greater than 3 to 0, I'm going to shade the other way because I want something that's more than 3 away from 0. So that's how the graph of that would look. So let's solve a couple of these and then graph them. So here's the first one. The absolute value of x is greater than or equal to 6. Now the steps to solve these are almost identical to what we were just doing with absolute value equations, except there's one difference. Step 1 is to make sure the absolute value is by itself, like you did last time, and it is. So the next step is to take whatever's on the inside, which we just have x, and we're gonna put an inequality between the positive and negative outside, so positive 6, negative 6. The first sign is going to stay the same. The only difference is when you set up the negative one, you need to flip your sign. That's the only difference. So now we need to graph this solution. Now when I make my number line, if I go ahead and look right here, I know I'm going to be graphing x is greater than 6. So when I make my numbers, instead of going from just negative 6 to 6, since I have to go greater than, I might just go up to 7. This would be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Oh, I got an extra one. Okay, so at 6, I have a closed dot because it's greater than or equal to, so it can equal 6. And it's greater than, so I shade greater than. And the other one is at negative 6, and it's a closed dot because it's or equal to, and I want anything less than that. So that is that solution. So here's another example. X, the absolute value of x is less than or equal to 0.5. First step is to make sure that the absolute value bars are by itself. It is, so then take the inside and keep your sign and have the positive outside, and then do the same thing except flip your sign and then make the other side negative. And these are your solutions. So now when I go to make this number line, I see that I'm going to want something less than 0.5. So I'm going to be shading towards the middle. And when you go to make your scale on this, you can go up by whatever you like. You can go up by 0.5s, 0.1s. I'm going to go up by 0.1 just because. Okay, I have a closed dot at 0.5. And then I have a closed dot at negative 0.5. And when I look at where I'm shading, I want less than 0.5, and I want greater than negative 0.5. So this is going to be in between. And if I look at my first statement, it said I wanted the distance to be less than 0.5. So if I start shading this way, my distance is going to be greater than 0.5, which doesn't make any sense. So if that happens, you should double check your math. Okay, here's the last example we'll try together. First step is get absolute value bars by itself. So we need to get rid of this 3. That would be the first step. Now the absolute value bars are by itself, so take whatever's on the inside, which would be negative 4x minus 5. Keep your sign and have the outside be positive, and then take the inside again. Don't change the signs on the inside. Whatever's in here, you don't change the signs. Write that down, flip your sign, and make the outside negative. Now you need to solve for x. So I add 5. And then divide both sides by 4, negative 4, excuse me. And since I divided by a negative, you need to flip your sign. And on this side, if I add 5, and then divide by negative 4, I divided by negative again, so I'm going to flip my sign. And it's a negative divided by a negative, so I have positive 1/4. Now when we go to graph this, I know some of you are already freaking out because we have fractions. So take a deep breath, everything's fine. And this one works out really nice because both denominators are 4, which works out perfectly for us. Since I have to go to a negative 11/4, I'm going to leave more room on my left side. I'm going to make this 0. And since we both have a denominator of 4, I'm going to go up by 1/4. So I'm actually going to move my 0 even further down here, because 1/4 is that first one. Okay, so if I go negative, I have negative 1/4, and just for the sake of this working out nice and simple, I'm not going to reduce my fractions. So you can see how simple this is to go all the way up to, or down, to 11/4. Whoops, don't ask me why I wrote an 8 there. Alright, my number line keeps going, but I'm just going to stop there because I don't need to go any further. This is going to be an open dot because it's not or equal to, and same with 1/4, open dot. And I'm shading less than 1/4, and I'm shading greater than negative 11/4. So it's going to be in between. As your graph. See, fractions are easy. So I want you to try these two. Solve them and then also graph them. So solve and graph.